Hello there. Another example for AP Physics 1. Some of you might have seen a contraption like this. There are plenty of loop-to-loops that are available, and some classes do labs on that. The very first one is strictly for the conservation of energy, so you probably know it by heart. Wake you up at 2 a.m., put you on your head, and you will be able to do this. So conservation of mechanical energy, then we just do UG equals K plus UG that was at point A. This is going to be C. And this is C. Kinetic energy at C, mg, 2 minus 0.5. That is 0.15 times 9.8 times 1.5. That would be your mv squared over 2. M cancels, equals 1.5 mg. M cancels. V is a root of 3g. 5.4. So 5.4 meters per second. B, we need to draw a free body diagram for the object at point B. At point B, it will have a certain amount of velocity, and assuming that it stays at the top, it will have centripetal force formed by gravity plus normal force. Depending on how fast it moves, it might move so slowly that there's no normal force, and if it moves even slower than that, it won't even stay on the loop. In C, they're asking us what is the minimum velocity for this object to actually negotiate this circular motion. So in that case, we're going to say mg is mv squared over r. In other words, gravity equals centripetal force. Then mass cancels, and your v is going to be the root of gr. That is going to be 9.8 times 0.6. That's going to be 2.42. In D, this was given to us as 2 meters. Now they're asking what is the absolute minimum for which our object would still be able to negotiate this loop-to-loop. We're going for UG minimum. Should be equal to K at the top plus UG at the top. So this is mg2r because it's at the top of the loop. So that's 2 radii. Kinetic at the top is going to be m, and then our v minimum squared over 2. And here we have our mg h minimum. Mass cancels. We end up with GH minimum. See how V squared was GR? So I'm just going to put that there as GR over 2 plus 2GR. Now G cancels, and we end up with H minimum. We have 2R plus half R is 2.5R, or 5 over 2R.